Ever notice the corner of a room, a pizza slice, or a sailboat sail? You're looking at a right-angled triangle, a shape with a secret superpower. For thousands of years, this triangle has helped build pyramids, navigate oceans, and even design video games. Its special 90-degree angle unlocks a rule that connects shapes and distances everywhere. Ready to see the world in a new way? Let's dive into the right triangle's magic and meet the ancient Greek who made it famous, Pythagoras. Let's get started. Prepare yourself because here it is, the legendary Pythagorean Theorem, a cornerstone of geometry, a fundamental concept that unlocks the secrets of right triangles. It's a relationship that has fascinated mathematicians and problem solvers for centuries. Sounds incredibly fancy, doesn't it? But don't let the name intimidate you. At its heart, it's just a proven math rule, a reliable tool that we can use to understand the relationships between the sides of a right triangle. It's a rule that has been tested and verified time and time again. The formula? The key to unlocking this geometric puzzle, a2 plus b2 equals sine c2, that's it. This simple equation holds the power to solve countless geometric problems. It's elegant in its simplicity, yet profound in its implications. That's all there is to it. But let's break it down to understand what each part of this equation represents. A and B are the triangle's legs, the two shorter sides that form the right angle. They are the foundation upon which the hypotenuse rests. And CC is the hypotenuse, the star of the show, the longest side always opposite the right angle. It stretches across the triangle, connecting the two legs. If you square the legs, meaning you multiply each leg by itself, and then add those squared values together, you get the square of the hypotenuse. The result is the area of a square with sides equal to the length of the hypotenuse. Imagine building squares on each side of the right triangle. The area of the two smaller squares built on the legs when combined will always perfectly equal the area of the big square built on the hypotenuse. It's a visual representation of the theorem in action. This remarkable relationship holds true for every single right triangle, regardless of its size or orientation. From the tiniest right triangle imaginable to the largest one you can conceive, the Pythagorean theorem always applies. So, if CE, the hypotenuse, is always the longest side of the right triangle, what does that tell you about its value in relation to A and B? How does the length of the hypotenuse compare to the lengths of the legs? Let us know your thoughts and insights in the comments section below. We're eager to hear your perspectives on this fundamental concept of geometry. Let's see the theorem in action with numbers. Suppose side A is 3 units, side B is 4 units. How long is C? Square 3, 9, and 4, 16. Add them, 9 plus 16 equals 25. So C2 equals sine 25. The square root of 25 is 5. The hypotenuse is 5 units. This 3, 4, 5 triangle is a classic Pythagorean triple. The process? Square, add, root. Works for any right triangle. Ancient Egyptians used this trick to build perfect right angles. If you know two sides, you can always find the third. That's the power of the Pythagorean theorem. The Pythagorean theorem. It sounds intimidating, doesn't it? But trust me, it's one of those mathematical tools that pops up in the most unexpected places. It's not just about abstract equations, it's about understanding the relationships between the sides of a right triangle. So, when exactly do you find yourself needing this ancient piece of mathematical wisdom? All the time. Seriously, once you start looking, you'll see right triangles everywhere, and with them, the opportunity to use the Pythagorean theorem. From simple home improvement projects to complex engineering feats, this theorem is a surprisingly versatile tool. Let's say you need to rescue a cat stuck 8 feet up a tree, and for safety, the base of your ladder needs to be 6 feet away from the tree's trunk. How long does that ladder need to be? This is where the Pythagorean theorem comes to the rescue. Remember, a2 plus b2 equals sine c2, where c is the length of the ladder, our hypotenuse. So we have 82 plus 62 equals sine 64 plus 36 equals 100. See how the theorem helps us relate the height and distance to the required ladder length? Taking the square root of 100, we find that the ladder needs to be exactly 10 feet long. Perfect for that feline rescue mission. But the applications don't stop there. What about TV screens? When you buy a TV, the size is usually given as the length of the diagonal, which, you guessed it, is the hypotenuse of a right triangle. So if you know the width and height of the screen, you can use the Pythagorean theorem to calculate the diagonal size and make sure it matches the advertised screen size. It's a handy way to double-check those specs. Ever been tempted to take a shortcut across a park instead of sticking to the paved paths? That straight diagonal path is the hypotenuse of a right triangle formed by the park's sides. And the theorem tells us that the hypotenuse is always shorter than the sum of the other two sides, making it a quicker route, assuming you don't mind the grass. The Pythagorean theorem is also fundamental in navigation systems, video games, where calculating distances and trajectories is crucial for realistic gameplay, and of course, construction, where precise measurements and right angles are essential for building stable and safe structures. Architects and engineers rely on it daily. From the design of skyscrapers to the layout of city streets, the Pythagorean theorem is a silent but essential player. It's truly everywhere. If you found these examples helpful and eye-opening, don't forget to hit that like button and share this video with your friends. Math isn't just a collection of abstract numbers and formulas. It's a powerful tool for understanding and interacting with the real world around us. So next time you're out and about, try spotting right triangles in the world around you. You might be surprised at how often they appear. And remember, the Pythagorean theorem is there to help you unlock their secrets. Alright mathletes, it's quiz time. Are you ready to put your Pythagorean theorem skills to the test? We've got 2 challenges lined up that will really make you think. So grab a pencil, maybe a calculator, and definitely your thinking cap. Let's see if you can solve these problems and prove you're on your way to becoming a true Pythagoras pro. Get ready, get set, let's dive into our first challenge. Challenge 1 focuses on a classic right triangle scenario. This is where the Pythagorean theorem shines. In this right triangle, one leg measures 5 centimeters and the other leg is 12 centimeters. Remember, the legs are the 2 shorter sides that form the right angle. Your mission, should you choose to accept it, is to determine the length of the hypotenuse. That's the side opposite the right angle, and it's always the longest side of the triangle. Think you know how to solve it? Pause the video if you need more time. Let's break it down. First, we square the length of the first leg, 5 squared or 52 equals 25. Next, we square the length of the second leg, 12 squared or 122 equals 144. Now we add those 2 results together. 25 plus 144 equals 169. And finally, to find the length of the hypotenuse, we need to find the square root of 169. The square root of 169 is 13. So, the hypotenuse is 13 centimeters. Did you get it right? Awesome. On to challenge 2. This time we're dealing with a kite flying high in the sky. The kite is soaring at a height of 15 meters above the ground. The string holding the kite is stretched out to a length of 17 meters. We're assuming the string is perfectly straight for this problem. The question is, how far away is the kite flyer from the point directly below the kite on the ground? In other words, what's the horizontal distance? Time to put on your thinking caps again. Let's solve it together. First, we square the height of the kite. 15 squared or 152 equals 225. Next, we square the length of the kite string. 17 squared or 172 equals 289. This time, we subtract the squared height from the squared string length. 289 minus 225 equals 64. Now, we find the square root of 64 to determine the horizontal distance. The square root of 64 is 8. Therefore, the kite flyer is 8 meters away from the point directly below the kite. Great job if you figured that out. As you can see, the Pythagorean theorem isn't just about finding the hypotenuse. You can use it to find the length of any missing side of a right triangle, as long as you know the lengths of the other 2 sides. It's a versatile tool. How did you do on these challenges? Let us know your answers and any questions you have in the comments section below. We're always happy to help and see how you're progressing. Remember, practice makes perfect. The more you use the Pythagorean theorem, the easier it will become. So keep at it, and don't be afraid to tackle new problems. If you enjoyed this quiz and want more math challenges, be sure to subscribe to our channel. We've got plenty more quizzes and lessons coming your way. Congratulations! With every problem you solve, you're one step closer to becoming a true Pythagoras pro. Keep up the great work. The Pythagorean theorem is ancient. Babylonians used it over 1,000 years before Pythagoras. Pythagoras and his followers were the first to prove it worked for all right triangles. This idea spread from Babylon to Greece, India, China, and the Islamic world, shaping math for centuries. Today, it's in your pocket. GPS uses it to calculate distances and find your location. From clay tablets to smartphones, this theorem has traveled through time. Math connects us across history. Sports fields are full of right triangles. In baseball, the throw from home to second base is the hypotenuse. Use the theorem to find the distance. Soccer players make diagonal passes, swimmers push off at angles, and basketball bounce passes all use right triangles. Coaches use these principles to design plays and train athletes. Even sports analytics uses a Pythagorean expectation formula to predict team performance. Math is the MVP behind the scenes. Next time you watch a game, spot the triangles in action. Architecture and construction rely on right triangles for strength and precision. Builders use the 3-4-5 rule to check corners. Designing a roof? The Pythagorean Theorem gives the exact rafter length. Wheelchair ramps? The slope and length are calculated with this formula to ensure safety. From skyscrapers to bookshelves, this theorem is everywhere. It guarantees stability and perfect fits. Math literally builds our world. The Pythagorean Theorem isn't just a formula, it's a way of thinking. It helps us spot patterns, solve problems, and see the world's hidden structure. Once you start looking, you'll find right triangles everywhere in nature, art, and engineering. This theorem is a gateway to geometry, trigonometry, and beyond. Math is the language of the universe, shaping everything around us. Thanks for joining this adventure. What was your favorite example? Let us know in the comments. Like, share, and subscribe for more amazing math and science.